Hey everybody, today we're going to go over Ohm's Law. This is just going to be a basic overview. We're going to do a couple of examples and I'm going to show you a cool simulation at the end. The video might be a little longer than usual, but I think it'll give you a good primer for when we start going into more math stuff with electronics. So as you can see, I have a calculator up. I just kind of found one on Google, and then over here I have a sheet talking about Ohm's Law. So let's go through it. So what is Ohm's Law? Ohm's Law is a formula that we can use to find parts of our circuit that we need to find, okay? So for instance, you're going to see, if you ever Google Ohm's Law, you're going to see triangles, I, E-R, I stands for amps, E, energy, volts, R, resistance, ohms. And this is basically what we're doing with it. So for instance, volts are on top here, we got amps over here, and then we got ohms. So this is how we would find certain things. So for instance, if you're missing, so when you're working on a circuit and you need to find the resistance of the circuit, you would get your volts and you divide it by your amps and you get your resistance. And it's pretty basic algebra, so we're going to go through some other stuff too with it. So this is our Ohm's Law wheel. So there's a whole bunch of different ways we can get our parts out, and it added for us power down here, which we can use throughout our examples also for formulas. So this is a little bit more in depth, so if you have power and missing one of these things, we can find the rest of the parts of it. Let me scroll over here. It's a little laggy today. Alright, so we got some notes. So for regular Ohm's Law, you're going to need 2 of the 3 parts of the formula for this to work. The cool thing, though, is we can, depending on how the circuit is laid out, we can kind of find those parts without using Ohm's Law. For instance, series circuits, we know that our current is going to be the same throughout the entire circuit. And then for parallel circuits, we know that voltage is going to be the same. So we can use this to our advantage when we're doing stuff. Over here, I have some examples for us that we can go through and figure out what's happening. So we can just like work our way through this a little bit, just to give you an example of how this works. So the first one we are missing our amps. So if we think about it, if we go back to our triangle here, we're missing amps, we have ohms, we got volts. That's how we get our amps. We're going to do some division. And that's how you get the answer to this one here. I'm going to show you after. We're going to go to a simulation to check out this problem. Now, when we get to our parallel circuits here, we have a couple steps we have to do. And this is also just getting our totals for current, resistance, and voltage. But in order for us to get what we need out of this, we need to first put our resistance together, and then we can figure out our volts. So for instance, we have these 2 resistors in parallel. We're going to do this layout right here, and I can just do it for us since we're sitting right here. Go over on the calculator. 1 divided by... Okay. And luckily for me, I made everything 100, so it's easier for me. Won't happen in the field, though. Divided by 100. Close that parenthesis. Plus, parenthesis, 1 divided by 100. And we're going to close that up. And it gives us 50. A good rule when you're doing anything with these parallel circuits is it's always going to be less than your lowest resistance on here. So they're both 100, it's going to be 50. So once we do that, we have our 50 resistor, and it's basically, now we just turn this into our, a series circuit now, right? So we can go through here, we know how many amps is going through here, and we know resistance is 50. I'll just throw it in here. Let me clear this, if I can think of how to clear it. Here we go. Alright, so ohms. 50 ohms. times 2 amps. That's pretty basic, right? 100 volts. Okay? Alright. I want to go over the simulation I have. Now, in this page, I have a link to the simulation, but I also just added it here. So let's check out the simulation here. So this is our Ohm's law. As you can see, got I for current, R for resistance equals our voltage. And the cool thing is, this is basically, I wasn't able to get it directly at 100 ohms here, but we could see here it is 29.4 milliamps for current. So that would be the answer for the other one on the page that we just looked at. But I just want to show you the difference here. When we start moving these around, we can kind of see how it moves, right? So let's see, we have 4.5 volts, and then if I move our resistance up and down, you can kind of see the relationship, right? How these all kind of play together. So what we're looking at, right, is the lower our resistance, the higher your current's going to be. Higher the current, lower resistance. And then if we go over here to voltage, higher voltage, our current goes up, lower voltage, current goes down. So I just thought it'd be a cool thing to show, just so you can understand how some of these relationships are. And that's all I have for Ohm's law. We're going to use it in a couple future videos, so I just thought I'd just give you a little heads up of what it looks like, what it is. See you then. Bye.